scarp length, and we're near some of the maximum offset, although it doesn't look like it. We're standing on the scarp. We're standing on the scarp. Now, why isn't it very obvious here? Because you're in shale. You're in the Hennessey Shale, and the scarp is degraded. In fact, where the dating was done was that way along the scarp. In the shale, where once the fault occurred, the more recent movement is one that was dated, the scarp collapsed and captured organic material, plant material in there that was scarp could be carbon 14 dated. That's where that date comes from. 1100, 1300, something like that, with fairly large uncertainty, but clearly a good carpet. Thank you, that's it. Yeah.
You say this is the scarp?
No, I'm down with it. Turn this way, we'll look this way first. It's behind some of the vehicles, but if you see the slope of those two telephone poles and it drops off the side, that scarp is this way. Now if you keep looking straight to the northwest, you see a little notch on right on the scarp. That notch, if you just stand between Richard right here, his head, that's scarp. We're on that notch. We're on the scarp. And if you look, this house over here is built on it. It just keeps going.
Yeah, don't be confused by the village just to the left, to the south.
It's right on the skyline.
There's a tree right on the south side of the scarp.
Right over the hood of the second.
Yeah, right over that.
Okay, that was what I was I was looking at that. I was looking for this guy.
Now this is the easiest place to see the damn thing because public property. But if you have topo sheets, if you'll just do the section line roads, you can follow this scarp all the way through this way for sure. It's all the section line roads cutting it both north-south, east-west as it goes across that diagonal. It's easy to follow it that way. So by the way,
yeah, new high-resolution aerial photography that's available. I think you can get it literally.
no, but you can see, you can find on Google Earth. This will show up on Google Earth.
Is there also a left lateral?
Yeah, I'm sorry. Yeah, the maximum offset is around 3 to 5 meters vertically, and about that much or a little bit more left lateral.
Left lateral.
So it's an oblique slip. Actually, it's an oblique slip.
And so what happens on
And the north side is up.
So was this reversed from the basin?
It's reversed from the original Pennsylvanian movement. That's what I never quite understood, and still don't.
Yeah. Well, it's a different
you won't
stress
find
regime.
anybody who
Well,
does.
of course, but it's always drawn. The Pennsylvania one is drawn with of course the south side up and the fault plane dipping to the south. This one, what was excavated, the two trenches that were excavated were over here on the Kimball's property, which is just between these cars and those trees. That's where the trenches were done. And what the trenches showed was sort of a north dip. But the north side is up now. With a little bit of in the soil.
So then a little forest.
Well, I don't know. I never, that part always was computer. Why was the present slip this way or surface this way and the Pennsylvanian one different? Something isn't matching it, but I don't know. That could be, maybe all that's resolved down the way.
How did the trenches resolve to strike slip offset?
Well, they have both strike slip and vertical. It's vertical to the north. I mean, it's
How did the trenches resolve the 7 meters of strike slip offset?
Well, okay, one of the clearest examples of the strike slip is if you go see those ridges that are coming off the mountain, there was a notch along there. What you can see on the ridge, you can take a topographic ridge, and you can see that it's offset, left lateral. And what you see is that the scarp height changes as you go over the thing, showing that the ridge actually has moved, topographic ridge actually has moved. I think that's really straightforward.
So what happens on either end of the fault? Or the
Well,
scar?
it just peters out. You just keep going until you can't see it. In this direction, it runs out against the Cache Creek floodplain. And you can't find it in the floodplain, which is 500 years old, that's in the USGS people say. And you don't, some other people think they can find it on the other side. I can't.
The relationship between the recent movement and the older one,
Yep.
is even more complex than this. We can map Cambria subbasin faults using seismic deflection. Most of the imagined seismicity is within the bottom, not on that big boundary side. And this is a northeast striking extensional Cambrian structure. The primary
is the Meers
structure at New Madrid, according to the first portion studies, is a southwest, northwest striking southwest dipping up to the north thrust fault. And that's kind of offset by some north striking slip faults. None of those faults go through any of the Cambrian.
Well, this is following Pennsylvania. And of course, Pennsylvania might have been also a Cambrian.
Well, that's what I was going to ask you. Do you think there's any evidence?
Well, I mean, in a sense, yeah. I mean, I think there must be something comparative going on.
Is there any, you can see it.
Well, I
This
don't
thing
know.
trends about here.
It just seems so likely.
I mean, I would about north of easy, but I can't.
Okay, folks, next stop is going to be lunch, and we're going to stop. We're not going to go right away to Lake Elmer Thomas. Rather, John has an area picked out where it's a little bit scenic, but there's also bathrooms. So if that sounds good to anybody, that's good, and we'll make lunch the next stop.